All right, so in this video, I'm going to walk through a few questions from the Regents packet that deal with some line relationships that we learned earlier in the year. So this was question number 19, and then later I'm going to do question number 16 about parallel and perpendicular lines, and question number 7 about a dilation of a line. So I'm going to start with number 19 first. What are the coordinates of point C on the directed line segment? And it gives us the coordinates of A to B and that the partitions are 2 to 1. So the question here is asking, where is part C on this line segment? First thing I would do is sketch this either in the blank space in the book or turning to the last page on the graph paper and actually going and plotting A and B. And I'm just going to show you how you can do it with just sketch paper or without a graph. So I see that A is negative 8, 4, x and y, and that B is 10, negative 2. So if I'm thinking about where on a coordinate plane these would be, A would be somewhere over here and B would be somewhere over here. So I know that this line is going to just generally go down. So what I want to find is how much it changed in the x of the horizontal direction and how much it changed in the y, the vertical direction. So I'm going to start with x first. So I'm going from negative 8 to positive 10 here. And so I can subtract these, I can count them, but it's a difference of 18 units. Then I'm also going to count the change in the y. So that's going from 4 to negative 2. So again, I can subtract these to find the distance. For 2 negatives, change it to positive is 6, or I can count them. That would be 6. So this overall change is 6. So what I wanted to do next is come back to where it talks about the partition or the segments, and it says it's 2 to 1. So if I add these two together, that means there are going to be 3 sections to this line. So what I'm going to do is I'm going to use the slope, is what we found here. I'm going to use the slope here and divide it into 3 pieces to find out what each of those pieces are. So divide by 3 equals 6. There's a change of 6 units to the right for each section. And I'm going to divide 6 by 3. So there's a change of 2 going down each time. So now I'm going to apply that 6 and that 2 to the original number to see where each piece is. So this might be where it's better to graph this on actual graph paper, because then you could physically count over 6. 1, 2, 3, 4, 5, 6, and then down 2. And you can keep repeating that each time. But to do it this way, I'd have to think, okay, negative 8, 4 is my first spot, and I'm going to go to the right 6, and I'm going to go down 2. So negative 8 plus 6 is negative 2. So that's my new x point. And 4 minus 2 is equal to positive 2. So the next point is negative 2, 2, somewhere over here. So I added 6 and I subtracted 2 because that's what we found here. So each piece changes by 6 and 2. So if I'm going to find the second piece, I'm starting now with negative 2 and positive 2 for x and y. So negative 2 plus 6 is positive 4, and positive 2 minus 2 is 0. So my next partition, my next segment is going to be at 4, 0. Now my graph is not great, but that's about where it would be. And I can just double check. Right now I could be done because I have 1, 2, 3 pieces to my line, which it tells me here 2 plus 1 is 3. So I have 3 pieces already, but just to be sure that I did all my math right, I'm going to find where that last and final spot was. And if I did it correctly, it will be this point right here. So I started with 4 and 0. I'm going to add 6, and I'm going to take away 2. 4 plus 6 is 10. 0 minus 2 is -2, and that is what that final spot is right here, 10, -2. So what I want to do is I want to count from my partition. I want 2 to 1, so I am going to count 1, 2. This is the point I am looking for because there are 2 partitions on this side and there's 1 partition on that side. So that is the point for comma 0. The answer to number 19 is 4.